All right, well, you get to see me, so that's also a treat, I hope. All right, cool. So welcome to this presentation. I'm going to talk to you about MVVM Light. Actually, not really. It's just an excuse. I'm going really to talk to you about .NET Core and .NET Standard. And the history of this presentation is that about 6 months ago, I was submitting call for papers for another conference, Visual Studio Live. And they have these new fast focus sessions, which basically are 20 minutes long. And I told them, I can show in 20 minutes how I took MVVM Light and ported it to .NET Standard, because literally it takes 20 minutes. And then they said, yes, that's great. Can you do it in 75 minutes? And I was like, well, OK, so I'm going to talk about a lot more than that. And now you have the 60-minute version of that talk. So basically, we are going to go through the history of sharing code, sharing files, how did we do things. Then we'll understand what is .NET Core, and then we'll understand what is .NET Standard. And most importantly, we will understand how the versions work, because it can be a little bit tricky, OK? So without further ado, if my pen clicks, yeah, it does. So I'm a senior cloud developer advocate. My name is Laurent Bugnion. I work for Microsoft since last year. My team is a large team. There are a few of us here. Who knows Damien? Yeah, everybody knows Damien. He came in yesterday, and then there was like, oh. So Damien is on my team. For example, he's doing more DevOps. I'm doing more Xamarin, cross-platform development, client application development, .NET development. And so each of us has some expertise. You will see us going around the world quite a bit, speaking at conferences, but really the main activity that we have is creating content. And you will see some videos, you will see some articles that we write, some GitHub samples. We work on the docs. It's not our main activity. We have a team dedicated to the docs, but we do help them. And of course, we also bring your feedback to the product group. So if you have feedback on some things that you like in Azure, that you don't like in Azure, feel free to reach out to us, and then we'll transmit that. And all the information you may want is here. So you have our Twitter list, where everybody is gathered, basically, summarized. And then we have our hashtags, and we even have a Twitter account. So check it out. It's actually a pretty cool team to be on and to work with. All right, so let's understand what is the key of the question here, right? And the key of the question is really about sharing code. This is what .NET Standard, .NET Core are going to help you with. It's about creating assemblies in a way that you can easily use them on multiple platforms, OK? And so initially, when we started with .NET, I started coding .NET in 2001. OK, it was .NET 1.0. And back then, you had only Windows Forms for the client, for the desktop clients, ASP.NET for the web. And in terms of client-side programming, that was it. And so you didn't need to share code. Basically, that was a non-issue. But then later, in 2006, WPF came out, so another desktop programming framework. But again, we didn't really need to share code, because you would choose either WinForms or WPF, but you wouldn't do a client in both. Okay? It's not something we did. So the real problem came a little bit later in 2007, 2008, when Silverlight came out. And, oh, Silverlight, I need to raise my fist. I raise my fist every time there is Silverlight, right? Sorry, we don't forget you. Just kidding. So Silverlight came out, and Silverlight was, if you think about it, kind of a smaller version of .NET. So suddenly, we had really two major versions of .NET to deal with. And not all APIs were everywhere. You had APIs in WPF, which were not available in Silverlight, and vice versa, because sometimes they were adding stuff in Silverlight before it was making it into the whole .NET, into the full .NET. So you had this problem of, OK, how am I going to know if I want to use an API, is it available here and there? And so what we were doing back then is what I would call develop preventively, meaning that every time we would use an API that we were not totally familiar with, we would go and check the docs. And then in the documentation, there was a combo box, all right, telling us, yes, you can use that on .NET, on the full .NET, or yes, it is available in Silverlight, et cetera. And then, of course, you had to share the code. And so one technique I'm going to show you was to add as a link. So add the file as a shortcut, meaning that it was built, but it was not how should I say, it was not physically present twice. It was only once in the source control system. And then sometimes you had to separate with pre-compiler directives, okay, just to avoid errors. And then you would build twice, once for WPF and once for Silverlight, and fix errors. All right. So that was kind of what we have. Now you can still add as a link. This is actually a legitimate technique which I still use sometimes, like in MVVM Light in my open source toolkit. I support multiple frameworks, and I share the files as a link, meaning that I have the file once, and then I share it, and then it's built multiple times. Also, for example, if you build Xamarin applications, if you build something in Android and iOS, and you want to share, for example, an image or some assets, you can also share as a link, okay, etc. Okay, and then came portable class libraries. So portable class libraries came out in 2011. So it's already pretty old, but it was a little bit of a revolution back then because it was the first time that we had a compiled binary, okay, an assembly, that we could use on multiple platforms. So now we didn't deal with sharing code at the source code level, but we dealt with artifacts, with assemblies, okay? So that was pretty cool. That was really useful, especially for people who did assemblies, who did class libraries. And the way that they dealt with compatibility was that they declared some profiles. So they were saying, OK, we have, for example, if we have a portable class library and then it supports, I don't know, back then we had maybe WPF and Silverlight, for example, then that's profile number so-and-so. And then if you add Xamarin to the mix, that's profile number so-and-so. And nobody had a clue about those profile numbers. For a long time, I thought I was dumb, but then I found out that nobody really knew what profile number 57 is. So I felt a little bit better. So it was really complicated, okay? And also, one of the problems of portable class libraries is that the result, the APIs that you were able to use were basically the intersection of what you chose. So if you chose WPF and Silverlight, then you had only the APIs that were both in WPF and Silverlight, which was a good idea, but it's also a flawed idea because it can lead to problems if you try to add something later, okay? So this is a least common denominator approach, and you can still create portable class libraries in Visual Studio. It's a little bit hidden now because you won't see it in the categories on the left. You have to actually search for them, all right? So if you enter in the search portable, in the template search, then you will find that. And notice that they are marked as legacy, all right? So Microsoft doesn't really want you to do that anymore. They are pushing you away from PCL, portable class libraries, into .NET Standard. Cool, so if I summarize, basically that's how it worked. Okay, you were created a new portable class library. You were selecting, for example, in that case, .NET Framework 4.6. And then you were adding maybe Windows 10. And then you were adding maybe Xamarin. And the result is the intersection of both. And of course, that, as you can see, can create a problem. Because if you have a class library which is already working on .NET 4.6 and on Windows 10, and then you go in production with that, and then later your boss tells you, oh, I need to support Xamarin as well, maybe suddenly your code doesn't build anymore. Because you add Xamarin, you have less APIs at your disposal, and then maybe one API that you are using is not there anymore, and so you can break things, okay? So what happened is that a few years ago, the .NET team came together and said, hey, we need to rethink compatibility from scratch. And so they decided to create something else, which is .NET Core. Before we do that, I'm going to show you a demo. And just so you saw that, I'm going to show you how we were doing about sharing files. And like I said, this is a technique which is still legitimate. Okay, so here I have two applications. I have one UWP Windows 10 applications. I have one WPF application. Those applications are built according to the MVVM pattern. I talked about that yesterday. Basically, it means that I need a view model. The view model is having the bulk of my code, okay? And so I have a view model which I prepared. So I'm going to add here a folder. Call that view model. And then in this folder, I'm going to add a file. And this file is a physical file, so it really exists. I just put it in my repo here. And so .NET Standard, here we go. And this is the file that I add, so it is physically present in my solution. But now I would like to take advantage of this file in my WPF, in the WPF version of my application as well. And so what I can do here is also add, oops, no, not that. I'm also going to add a new folder. All right. And now instead of taking this file and making a copy, which is annoying because then I have two versions of the file in my source control, okay? I need to maintain two versions. I'm going to go and say add existing item. And then I can go into my UWP application, take this file and select here, add as a link, okay? And so basically what this does is create a shortcut to the file in the project file. Another way to do that, by the way, if you want to go faster, is take the file. This thing is not very stable. Is take the file, drag it, but as I drag, I press the Alt key. And so this is creating a shortcut. And now you know it's a shortcut because there is a small arrow. Okay, it's very subtle, but you can see that. And what it means is that if I go in Windows Explorer, there is no file. Okay, the file doesn't exist physically on the drive. However, it is going to be used by Visual Studio when I build. So now I'm building my solution here. There are a bunch of errors which are going to disappear. It's just because the restore didn't take place yet. Okay, so now the build succeeded. I'm going to run, for example, the UWP version of the application. All right, so that's the Windows 10 version. Here we go. Let's make that a little bit smaller. Now what this does, if you check the main view model here, it's going to connect to an Azure function, taking my name, and then it's going to return whatever the function does, and in that case, it says hello. So I'm just going to type that, press, takes a short while to connect to the Azure function, and now it says hello from NDC Sydney, so it works. And I have exactly the same functionality in the WPF application. So if I start the WPF application now, you see that slightly different look and feel. Okay, this is normal. Press. Now after a short wait, it comes back. So I have exactly the same functionality, but I have two versions of my application. All right? We were using these type of techniques heavily, for example, when we were doing WPF applications and then a Silverlight companion with maybe less functionality. Or nowadays, if you do, for example, some WPF application for the desktop, and then you have a Xamarin companion for mobile, for example, that would work. But like I said, .NET Standard is a better approach. So that would be how we were sharing files. And now I'm going to show you the portable class library approach. Okay? So here I have, again, the same type of application. This time I have three versions. I have an Android one, UWP, and WPF. And so this time, instead of adding the file as a link, I'm going to create a new project. So I say add new project. Here, I'm going to go in the search, like I said, and search for portable class library. I find it, all right? It is legacy. I'm going to call that portable.data. Okay, and now I can choose what frameworks I want to support. So I said I need Windows 10, .NET Framework for WPF, and Xamarin. I say yes. And now I need to start wiring things up, which is a little bit annoying, but you do it this once, and then you don't have to do it again. So first of all, let's add the view model file here. I need to add the file itself, so it is the same file as before. Here, .NET Standard, main view model, all right? And now I need to add also some connections. So I need to say, okay, the Droid version of my application needs a reference to the data, all right? Then I also need a reference from my UWP to the same one. So this part is a little bit tedious, but of course you do it once only. Now the huge advantage of this approach is that if you add more files to the portable class library, they get added automatically to all the versions of your application, and so of course it makes sense. So now I have UWP. If I run it, no big surprise, it's going to just work. Or it doesn't, for some reason. Anyway, you can believe me, right? This is exactly the same version that I gave before. There seems to be a problem with the restoring of the NuGet package, but basically that would be the approach. Okay, so now, like I said, right, big problem with this approach is that if at this point I decided to add support for a new framework, then suddenly maybe things are breaking because I might have used an API in my main view model. For example, let's say that HTTP client for some reason doesn't exist in one of the frameworks, and then my whole things break. So that's an issue, and this is what .NET Core and .NET Standard especially are going to try to fix. So like I said, a few years ago, the team came together, decided, hey, we need to rethink the whole thing. So let's start from scratch. And what they did is that they created a new implementation of .NET, because .NET is basically a specification, right? And so you have multiple implementations of that specification. In fact, we already have multiple implementations. For example, we have the full .NET. We had back then Silverlight. We have Windows 10, which is an implementation of .NET. All right. We have Mono, which is an open source implementation. Xamarin, which is somewhere in between, if you want. And they decided to create a new implementation. And so they took just a small subset of APIs, just what was needed to run web servers, web applications, and maybe some console applications. So they were quite heavily headed to the server with that very first version. And then they called it .NET Core 1.0. All right? Now, the really cool thing with .NET Core 1.0 is that even though you had only a few subsets of APIs, the cool thing is that it was running on Windows, on macOS, and on Linux. All right? So for the first time, we were able to deploy web applications to Linux, which is a big deal to us at Azure, because in Azure, you can actually create a web server running Linux and deploy an ASP.NET Core application to it, like I will show you in a moment. So that was good. Like I said, main usage for web applications, okay, console applications, these kind of things. But again, we have the same issue that we had before, which is if I want to use an API, which is in .NET, how am I going to know that it is actually supported on Linux, that it is actually available to me? And to solve that, they decided to create a specification, a contract, if you will, which is called .NET Standard. So .NET Standard is a contract, and .NET Core is one of the implementations of the contract. So basically what it means is that if you say, OK, in .NET Standard 1.0, we specify that we have this API, this API, this API, any framework which implements the specification has to implement this API, this API, this API. Otherwise, they may not call themselves .NET Standard 1.0. OK? So now we know for sure what APIs we have at our disposals. If suddenly we see, oh, .NET Standard 1.0 is not enough, maybe I need to go to 1.2, 1.3, because those versions have more API. And the other promise that we get from the .NET team is that the versions are always backwards compatible. So if you have a version like a .NET Core application which supports .NET Standard 1.6, that can use an assembly which has been created with 1.5, 1.4, 1.3, 1.2, 1.1, 1.0, okay? Because this is always backwards compatible. All right. Good, so now the really good news is that .NET Standard is a full-class citizen in .NET these days, and so all the .NET clients that you can build these days support class libraries built in .NET Standard. All right? So we can use .NET Standard already in a WPF application. Okay? We can use them in UWP. We can use them in ASP.NET, ASP.NET Core, in Xamarin. And of course, we can use them with all the tools that we have, Visual Studio on the desktop, Visual Studio for Mac, Visual Studio Code, which you can use, for example, on Linux, on Windows, or on Mac. And so you can create ASP.NET Core applications like that. That's pretty convenient. And so let's take a look at those APIs, okay, and those versions. So in .NET Standard 1.0, it was a small subset of APIs, like I mentioned multiple times. But the good thing is that it was supported by a large number of frameworks. So you could literally build a Windows Phone 8.0, not even 8.1, okay, Windows Phone 8.0 or a Windows 8.0 application, and reference a class library built with .NET Standard 1.0, all right? But like I said, small subset of API. So if you need more API, you can upgrade. For example, let's say .NET Standard 1.6, then you have more APIs. But you see suddenly there is a problem, which is that some version of the frameworks don't support that anymore, okay? So if you have a class library built with 1.6, you cannot use it in a Windows 8.0 application anymore, which most of the time is fine. But if you go to the .NET framework, for example, that might be an issue sometimes, because if you have a WPF application built with 4.5, running in enterprise, you have a set of PCs running .NET 4.5 there, and then you come with a new class library built with .NET Standard 1.6, well, that requires .NET Framework 4.6.1. So you need to upgrade your whole enterprise to that version, and that can be an issue. So you always need to think about that, especially if you are a class library creator. Try to aim for the lowest version possible of .NET Standard, because like this you support more people. Okay? Now in .NET Standard 2.0, which is a current version that we have, as you can see, even more APIs. Okay, they talk about 20,000 new APIs. That's great. But of course, it means that for a .NET Core application, then you need to upgrade to 2.0. For Mono, you need to go to 5.4, etc., etc. Okay? Good. So if I summarize those versions, now this is a small extract of a huge table which is available here. Don't fret. It's not that bad. Basically, what this table tells us is that if you build an application, try to aim for the highest version of your framework as you can, because then you will automatically be compatible with all the versions of .NET Standard. So if you build an app with .NET Framework 4.6.1, you will be able to use class libraries built with whatever version of .NET Standard as there are. If you build an ASP.NET Core 2.0 application for the web, then you can use, again, all versions of .NET Standard. Okay, so that's the guideline. If you build an app, try to aim as high as possible. On the other hand, if you are a class library developer, try to aim as low as possible, because if you support .NET Standard 1.0, it means that you are compatible with basically everyone. Okay? Now, if you have APIs that you really need in your class library which are not in .NET Standard 1.0, then maybe you go one higher, but then you support less people. That's kind of the takeaway on that. Okay, so I would like to show you a demo of ASP.NET Core on Linux, and this demo takes about 15 minutes to do completely. And so I didn't want to spend the whole time on that, because a lot of these 15 minutes are spent waiting for Azure to actually provision and to do the stuff. And so instead, I created a video that I'm going to show you, and I'm going to comment as we go. So what this video is doing, as you can see, I'm doing this in a command prompt. So I'm on Windows. I could do exactly the same in Visual Studio if I wanted with a UI. I'm going to create a new folder. And then in this new folder, I'm using the .NET command to create a new Razor web application. Razor is a template, so it's going to allow me to mix HTML and C#. And this is an empty template. It just has a landing page, which you can see now. It is running in localhost locally on my Windows machine. So now I'm going to start putting things on Azure. So the first thing I do is that I create a Git folder, not GitHub, right? Git locally on my machine. I add everything. And then I'm going to basically tell Azure I want to deploy using Git on Azure. Now I go to Bash on Azure in the portal. I can run Bash directly in the terminal. I also have PowerShell if you prefer. And here I'm going to use Bash to create a new resource group. Like I said, you can do all that directly in the portal. You can also do that from Visual Studio if you prefer. It's just another way to do things. So I'm creating my resource group in West Europe, because this is where I'm from. Then I'm going to create an app service plan. Basically, I'm going to say, OK, for my web server, I need so much RAM, so many cores, so much bandwidth, etc. Here, I'm going to choose a small plan called S1, which is like a cheap, small service plan. So SKU S1. And then I'm going to say is Linux. So I'm telling to Azure at this point, this web server should run Linux. All right? Then I'm going to create the web application itself. And I say, OK, it goes into this resource group that I just created. It is going to use this plan that I just created. And at this point, I'm going to say, all right, I'm going to use, for the runtime, I want to use .NET Core 2.0, because I want it to run on Linux. And so it needs to be compatible. So .NET Core 2.0. And then I say the deployment has to happen through Git. So I will have a repo in Azure. Okay, I will have my local repo, and then I'm going to connect to that. To do that, I need a URL, which is given to me gracefully by Azure in the beginning here. And so now I can go back to my Windows environment, and I'm going to configure Git to push to that repo on Azure, and I'm going to do the first push. That's the part which typically takes a few minutes to complete. Here, I kind of speed everything up through the magic of video. And once this is done, I'm going to have my website deployed on Azure, running, because here I push directly to production. Don't do that. I did, but you know, it's a demo, right? And you will see that you have exactly the same template, but this time it's running remotely on Azure, on Linux, and you don't see any difference. So once the deployment is done, I go back here to my portal. This is the URL of my web server. I'm going to click, and now you see that you have exactly the same thing. Now I can go back on Windows. In that case, I'm on Windows. I could do the same thing on Linux as well. I'm using Visual Studio Code, which is our cross-platform editor, so that runs on Linux as well. I'm going to just edit one of the Razor files, one of the HTML files, if you will. And then the cool thing is that I can deploy directly from code because I have the possibility to push to Git. And since my pipeline is already set up, so I'm going to commit. I'm going to push to Azure. Visual Studio Code knows about my remote repo because it is all set up in Git. And now if you go back on Azure and click, you see that the change has been deployed, okay? So again, right, this is the hipster way of doing things with the command line. You can do that with a fat, big UI if you prefer. I know that personally I do. I prefer to use the UI, okay? Or you can do that directly from code. I mean, we have plenty of ways to do things. But the cool thing is that, in the end, we have a web server running on Linux, which can be an advantage, okay? Some people prefer that because of cost or because of different things, resilience, etc. So it's a nice way to do. And as you could see in the beginning, I tested my whole deployment on Windows first, so everything's working as it should. All right, so now let's talk a little bit about the topic of the discussion, if you want, which is how I took MVVM Light and ported it to .NET Standard. So MVVM Light is an open source library. I published it the first time in 2009, so it's already quite old. And in the beginning, I had just WPF, and then I added Silverlight, and then I added Windows Phone, and then I forget what I added, probably Xamarin. Basically, at some point, somebody reached out to me from Microsoft and said, oh, we would like to take your project and put it on portable class library because we are releasing this portable class library thing now, and we'd like to test the conversion, if you wish, with a few projects. So is your project okay to do that? I said yes. And they did the work, which mostly was easy. I would say to 90% the conversion is easy, and then the 10% that remain can cost you a few hours, days, maybe weeks, right? So in our case, it was not too bad. And I ended up with an architecture, which is a portable class library-based architecture, okay, which is like that. So you have the core components, which are in a portable class library. And this portable class library supports a range of things. It even supports things like .NET framework up to a certain point. It doesn't support Silverlight because adding Silverlight to the mix was kind of tricky, so I removed it, etc. But basically, I support a large number of frameworks. And then at the time when I created MVVM Light, I also wanted to have an IOC container inside it. And there was a good idea, or at least we thought it was a good idea at the time, floating around. I'm talking 2010, 2011, like that, which was to support a specification specified by Microsoft patents and practices, our research department, if you want, which was called the Common Service Locator. And the idea was to say, all right, if you have an IOC container and you implement the Common Service Locator architecture, you're going to be able to swap the IOC container with another one just very easily, all right, because we all support the same interface. And so it sounded like a good idea. In retrospect, it's not really a great idea. I'll tell you a little bit later why. But back then, I thought, yes, I want to be a player in the community, and so I'm going to support Common Service Locator. And so I put my IOC container in another assembly, which I call the extras. Why did I put it in another assembly? Well, you see, MVVM Light is used in a large number of places, including some firms where they have to go through a procurement process. Every time they want to add one single assembly, they need to do procurement, and it's a lot of paperwork. And they don't like to do that, which is understandable. And so if they want to add MVVM Light, it's one thing, but if they also want to add Common Service Locator, then they have to fill again a set of papers. And so I decided, okay, if they don't want to do that, the extras, they can just discard it. They don't use it at all, but they still can use the main the main assembly of MVVM Light. So that was kind of the idea. Okay, so we have, of course, some references, all right? And then after that, I also have some platform components. So for example, in Android and iOS, for the native Android and iOS, I also support data binding. So I have data binding system, which works only on Android and iOS. And so it makes sense to have those in a platform assembly. For example, I have one for Android, one for iOS. I also have some components which are specific to the full-blown .NET. And I have some for UWP. So I have those platform assemblies which also take reference on the main. So that's the architecture of the portable class library version. And now I can refactor, which is always great because this is when you can fix errors, all right? So the common service locator, I don't like it. Now there is a reason. The reason is that, first of all, it's a dependency to a third-party component that I don't own, all right? Which, of course, is slowing me down. And when I decided to do the port to .NET Standard, they didn't support .NET Standard yet. So at this point, I have two options. Do the port myself. It's an open source project. I could do a pull request. But, you know, it's a lot of work, right? And also, I was not even a contributor, so who knows if they will accept my pull request. And also, the other thing is that really this common service locator, it sounded like a good idea in 2010, 2011, but if you think about it, how many times are you going to swap IOC container in your application? Maybe once, at most, right? Usually you have an IOC container you like and you stick to it, all right? So basically, it's a clever solution to a problem that doesn't exist, I would say. So I decided to remove it completely. Now that's going to be a breaking change for my users. So if they have an application using the portable class library version of MVVM Light and they decide to go to the .NET Standard version, that's going to break their application, so you need to document that carefully, okay? In my case, I feel that this is a step which is big enough that it warrants a few breaking changes, so I decided to go with it. So now that I don't have common service locator anymore, I don't need that second assembly anymore either, so I only have one assembly, which is called the standard version, all right? Now for those platforms, of course, they take reference on the PCL version. That's not going to work, so I need another version of those. It's exactly the same code, except that it is taking reference, this time, to the standard version. So that's the new architecture. It is simpler, which is a good thing. All right, so now what I would like to do is show you a demo of the port, because like I said, this is something you can literally do very fast. Now the reason why I can do it very fast is because I already did the port to the portable class library. That one was relatively painful. So if you have an assembly, which is a full .NET assembly, and you never did the work to put it in a portable class library, going from that full-blown .NET assembly to .NET Standard might cause you a few headaches, all right? Because there are some things which are not going to work simply because it's cross-platform or simply because some APIs are missing. However, if you did the port to portable class library already, then that's going to be relatively easy, and you shouldn't wait longer, in my opinion. So in order to show you the demo, what I'm going to do is go to GitHub. So this is a full repo of MVVM Light on GitHub. I'm using Git extensions here to show you the demo. And basically, I can go down in time, and I'm going to find the label, which is 5.3, which is a version before I did the conversion. And then I'm going to check this out. Basically, we are going back in time to a time where .NET Standard didn't exist yet. All right. Cool. So now I have this version here, and I can go to my folder. Oops. Here, and I'm going to open MVVM Light in Visual Studio. Now, you will see a bunch of projects which are not going to be supported. Those are old versions because, again, we went back in time about a year ago, okay? So I still have some Silverlight project here. I have a few things. And here I will say do not load the project for those projects which are causing issues, because really the one I want are just the portable class library one so that I can copy those files. All right, so now you have here the architecture that I was talking about before. So we have the PCL version. Now I still have a few remains of the past, like Silverlight 5, .NET 4, .NET 3.5. I kind of continue to maintain those because some people are still using those, if you believe it. I have the extra. And then I have the platforms for the different platforms, including Android, iOS, etc. So what I'm going to do now is add a new .NET Standard class library. So I add a new project. I go to .NET Standard class library. Let's call that galasoft.mvvmlight.std, for example, for standard. And one thing I need to do here is that you remember I told you for the class libraries, I want to aim low, all right? So let's try to build that for .NET Standard 1.0, okay? Now, by default, it actually creates a 2.0 project, which is not what I want. So I'm going to fix that by changing it to 1.0, okay? All right, and now we are going to start copying items. So I will go to the PCL version of MVVM Light. I'm going to take all the files. Now here in the real-life version of the project, I did add as a link, because again, I want one version of those files. Here, in this demo, I'm going to copy them, mostly because it's faster to do it this way. I don't want to spend time adding as a link everywhere, so I'm just copying them. But in real life, you would do add as a link, and then you would try to fix the errors like that. OK, so now I have this version here. Let's try to build, and we are going to see what happens. Well, full disclaimer, it's not going to build, right? We need to fix a few things. Otherwise, I probably wouldn't even have submitted a session at all. However, the fixes are going to be relatively easy, so that's the good news. So one error that you're going to see popping is that I'm using an API which .NET Standard doesn't support. And that is something that I knew already. All right, this is this message box result type. Okay, this is not supported on .NET Standard. And in fact, I knew that already. I already deprecated that class, the dialog message class which is using that. You see, I'm saying this is obsolete. Okay, I don't recommend using this class because at some point it's going to disappear. And so I feel that now is a good point. So I'm going to completely remove this class from the .NET Standard version. So again, it might be a breaking change, but I gave ample warning to my users. Okay, this obsolete warning has been here for already a couple of years. I feel that now it's a good time. I can remove it. All right, now we have a few things more which are going to cause issues. And so, for example, I have those threading here which are not in .NET Standard. Why not, you may ask? Well, it's simply that we have already a couple of versions of .NET floating around, okay? And we have one which is using NetFX Core, which is a UWP version. When they release Windows 10, they changed a few things. Mostly it's about namespaces. Mostly the classes are still there, the API is still here, but it lives in a different namespace. And so in order to fix that, I'm going to tell Visual Studio that this .NET Standard project is actually closer from a portable class library and from a NetFX Core library. And like this, since I already have the precompiler directive in place, it's going to use the correct namespaces. Again, the first time you port from a full-blown .NET to a portable class library, that's the kind of things which is painful. But if you have already a portable class library, you say, my .NET Standard is following the same conventions as my portable class library, and then normally it should work pretty well. So now I'm going to build this. And normally, if everything goes well, it should build, and that shows you that pretty much it was relatively painless to do that. You see how I tend to speak before it's done building? That's very bad idea. All right, no, it did build. OK, so build succeeded. So basically, my core components are ready to go. All right? Now, I still have the IOC container. So let's go and take that. It's in the extras. Like I said, I can put everything in the same assembly now. So I'm just copying that. And I'm going to build that and see what happens. And now again, not a surprise, it's not going to build because I have something missing. I have the common service locator, which is missing. you see this namespace here, Microsoft.practices.service location. That's the common service locators that I mentioned before. Now, I said I don't want to reference that anymore. So I'm going to remove that code here to make that a little bit bigger. Here we go. I'm going to remove here this interface. So what it means is that now I'm breaking my users' applications, all right? So I have to give them warning and tell them why I do that. And then if I check again, I have another one of those references here. And now I'm also going to have a few of those exceptions which I need to replace. So I have those activation exceptions. This is a type which is coming from the common service locator component. And here I decided in .NET Standard, I'm going to replace that with an invalid operation exception instead. And so again, that's a breaking change. Okay, if my users were trying to catch activation exception in their code, well, suddenly it's not going to build. So you need to tell them why and maybe give them a beer next time you see them. Okay? It's always a good idea anyway. Cool, so now I can try to build again. And this time it's just going to build. So basically I did in front of you the port of a fairly used project to .NET Standard, and it was painless. I think we can say that. So now, why did I even do that work, right? What can I do with that? Well, for example, I could use that to build an ASP.NET Core application. MVVM Light is rather a client application framework. It's rather used for rich clients like Xamarin, etc. But I know that a lot of people use it on the web as well. They like the IOC containers. They like the messenger. They like a few things. So that works. But here what I'm going to do something else. I'm going to build another application, and this time I'm going to do a console application. Let's do a small utility app, okay? So let's create a project, and I'm going to take a .NET Core application, and I'm going to call that Core with MVVM Light. And now this creates a standard console application just like we are used to in the full-blown .NET. And I'm going to start adding a few things. Here we go. So the first thing I want to do, let's imagine, okay, for the demo, that this is a utility application that is going to connect to the web and do some things. So I'm going to start by saying, let's add a service. So I'm going to do things neatly. I'm going to add a folder, model, and then in this folder, I'm going to add an interface. And I'm going to call that iData service. All right, this is going to be public. And this iData service, what it's going to do, again, let's imagine that it's a utility application. It's going to connect asynchronously to something, take an integer, take two integers, and return the result, which is going to be the addition. Okay. Good, now I can implement this service. So I'm going to add a real, like a production implementation for that. So I add a class, data service. I'm going to say this is public. This implements iData service. All right, and now I'm going to add the actual implementation. So first of all, I'm going to add a URL. Now again, this is an Azure function. And this Azure function, I'm not going into functions here, but basically this is serverless code. There is actually a server, big joke. Basically, it's running somewhere. I don't know where. I don't have to care about it. It's just some code I pushed online. It's going to take, as you can see, two parameters, one parameter here, another parameter here. It's going to return the addition to me. All right, so very easy way to build APIs. But basically, in this example, it doesn't matter. It could be any API, and this is just going to work. All right. Cool, so now let's build the application itself. So here I'm using HTTP client, which is a well-known way to connect to the web in .NET. This is asynchronous, so I need to declare that async, all right? Now I'm going to say, take the URL, replace the first number with this number here, replace the second number, and then return the result. And this is all asynchronous, as you can see. Okay, so now that's cool, but maybe I would like to have an offline version of this service so that I can do tests. All right, for example, if I want to unit test things and my service is running in production, I don't want to touch that. So that's OK. I have an interface already. All right, I can easily add another version, and I'm going to call that test data service. And test data service, same story. It's going to be public. We need to implement iData service also. But this time, I'm going to simulate the asynchronous operation. I'm using a task completion source. This is a class which allows me to basically run an asynchronous operation synchronously if you want. So it's going to help me simulate. And whenever I call this service, it's going to say, I don't know how to count. I'm just a test program. All right? So it basically doesn't do anything. All right, so now let's build the program itself. Let's build the utility. Now, of course, in this simple example, I have everything in the same project, all right? So you could think, oh, why do you even do that? It doesn't matter. But in a real-life application, maybe you have multiple components. So one good way to do these kind of things is to use an IOC container. So I'm going to do that. So the first thing I need to do, I need to ask the user, what do you want to do? Do you want to use the test service, or do you want to use a real service? All right, I'm going to get here the result. Then, depending on what I do, I'm going to use simple IOC, which is an MVVM Light class, to say I want to register that every time somebody wants to use the iData service in the application, please give them the test version. Or, if the user selected 2, I'm going to say every time somebody wants the iData service, please give them the production version of the service. Now, of course, I need to add simple IOC. Well, the good thing is that we just did that. So here I have 2 possibilities. It's on NuGet, so I can just add it through NuGet. Or in that case, to prove to you that this is a real thing, I'm going to add a reference to the component that I just ported. So I go in MVVM Light. Here, I'm going to go down to the STD version that we just created, debug. Okay, you see that this one is empty. It's only here because when I first created the class library, it selected 2.0. Okay, so it's just an artifact. But the real thing is going to be here. So I'm going to take this version of the assembly, add it as a reference. Again, that's something you would do normally through NuGet. So you go and search for MVVM Light .NET Standard, and then you find it. All right, so now this is available. I'm going to register iData service, test data service. Everything is OK. Now I'm going to ask the user to give me the first and the second number. All right, I make sure that those can be parsed. And then I'm going to compute the result. Now, to make things a little bit more interesting, I'm not going to do that here because I wanted to kind of show you why I did the simple IOC dance, okay, the IOC container game. And so I say, okay, let's do that in another program. In that case, it's all in the same project. In real life, it would probably be another component. And basically, the key of the matter is that this one doesn't want to know if it's using the test or the production version of the service. It only wants to call get result. And now it can do that, okay? Just need to add a few namespaces, simple IOC. So this guy here is saying, hey, give me whatever version of iData service is registered, give me the instance, and I'm going to call the service. So that's how you decouple your, for example, your test program from your real program, these kind of things. All right, now I'm on Windows. I can run this. So let's do that. It's going to start in a command window, as you can imagine, all right? I can choose to use the real service, for example. Let's say 30 plus 12. It is, of course, going to return 42 because it's the answer to life, the universe, and everything, so of course. And basically, I also have the time on server. So it called my function. It comes back. It works. This is great. We know how to do things on Windows. No big question. If I use a test service, it's going to tell me, I don't know how to count. I'm just a test program. That works. OK, now you will tell me, well, why did you do that? We knew how to do that. Right. But now you can also do that because it's .NET Core on Linux. So I'm going to publish this application. Publish means it's just going to package the .NET Core things with everything I need. And I'm going to put that into a folder. Let's I need to do something that I forgot, almost forgot. On Linux, we don't support 2.1 yet. This is the latest version. I'm going to switch that to 2.0. Okay, I told you try to go as high as possible. But on Ubuntu, we don't have 2.1 yet. So as high as I can go now is 2.0 on Ubuntu. All right? So 2.0, I'm going to rebuild that quickly. OK. And now I'm going to publish this time. Let's do a new profile, folder, 2.0 publish. All right? So basically, it's taking everything it needs. I'm going to show you what it created. In bin release 2.0, there is a publish folder, and this is what you need. So basically, it looks exactly the same than you would expect, except I don't have an exe. All right? These are all DLLs. Why no exe? Well, exes are very complicated because on Linux, it doesn't look exactly the same as on Windows or on Mac or on whatever. So here we have DLLs. All right. I'm going to take this folder. And now at this point, I would say, oh, my server runs Linux. I'm going to put it there, and then I can run it. But I can actually test that on Windows because we have something on Windows which is pretty cool, which is called the Windows Subsystem for Linux, WSL. So let me put the publish files into C. Like this, I can find them easily. And if you go to the Windows Store, you can find, and you type Linux in the search, you will find those applications, so you can choose which distro you want to use. In that case, I selected Ubuntu. And as you can see, it is installed. So I have Ubuntu installed as an app. And now I'm going to start typing in bash in Ubuntu. So I say cd for change, / that's a / for you because I'm on Linux now. mnt, which is where I mount my files. C, publish. All right? And inside there, I told you I don't have an exe, so I'm going to run .NET executable, which is going to run my core with MVVM Light DLL. And I'm running exactly the same program as before without any change, but this time I'm on Linux. Let's use the real service, 12 and 30. And here it's using HTTP client to connect to an Azure function and to return the result to me, hopefully soon. Can you stop using your smartphones for a while? No? Anyway, at some point, it will return and then give me, here we go, and then give me the whole JSON. All right? So I have .NET running on Linux using HTTP clients, using all the APIs I have at my disposal, which I think is pretty cool. And it's also using MVVM Light under the cover for the IOC container. All right, so if you decide to do the port, which honestly I recommend, a good place to go is this address. This is where you have the .NET Portability Analyzer. It's a tool that you install on your machine, and then you just feed it some DLLs, or exes, for that matter. It's going to run an analysis. It's going to check every API that you're using, and it's going to tell you, you can go on this version of .NET Standard, you can go on this version, et cetera, et cetera. Then it's going to underline for you where are the issues, and it's going to point you to some possible solutions. That's a really good tool to get started with. I would really recommend that you look into that because, as I said, the compatibility story for Microsoft moving forward is going to be .NET Standard. Okay? Portable class libraries are the past. They are legacy already. In a future version of Visual Studio, I wouldn't be surprised. I don't know. I'm not on that team. But I wouldn't be surprised if at some point they just vanish. Okay? So think of moving your code. It's not a huge deal. I want to give a plug, even though this is not a Xamarin session, but if you're interested in cross-platform and you're in Sydney, you can go to this meetup. It's in the Reactor Hub. It's about 10 minutes by walk from here. And it's a very nice space that we have there. And Alec Tucker is running that. So if you want more information, contact him. Here I have a resource slide. So there is an overview of .NET Standard. The demos that I showed you, the ASP.NET Core on Linux, you can see it here as well. And finally, everything you need is at gslb.ch/NDC Sydney 18-2. That's because I had 2 sessions here. And if you give me a few hours, maybe a couple of days, I'm going to put everything there. I had a few technical issues which explain why it's not ready yet. But basically, you'll get the slides, the repo, the small videos that I showed you. Everything is there. And hopefully, this was useful to you. If you have questions, I still have about 5 minutes to answer those. But if you don't, feel free to, go or come say hi if you want. Thank you very much for your attention.